Hi there. Well, this is our last section that we're going to be looking at. This is 11.6. And I do have a slight introduction here just to kind of give you an overview of what we're going to be looking at and what we're going to be trying to do. And I'll try not to let this be too long because I also wanted to look at some of your homework, do some of the homework problems, just to show you how to use my math lab with graphing these parabolas. But once you start the homework, it's not going to take very long. So this video is probably going to be a whole lot longer than it's going to take you to do your homework. Okay, we're going to be graphing quadratic equations, and you know that quadratic equations, the highest power is a squared. Well, there are actually a couple of different forms in which you can see the quadratic equation. And again, they form these parabolas when you graph the solution. One of the forms looks like this. Now, if you wanted to, you could rewrite this where, A, H, and K are numbers. All right, and we'll look at some examples here. You could multiply this out and have it look like this. Well, let's go ahead and look at a couple of examples of a quadratic equation that's written in this form here. And this form is very helpful for graphing. It makes it really easy, even though this isn't too bad. This is 11.7, and we just are running out of time. I want you guys to have a chance to review for your final. So this would be 11.7. You can always look at that on your own if you want to. Well, anyways, in this form right here, and you could get to this form, you could go from here to here by completing the square. And then you could go from this form back by writing this out twice, multiplying everything by 3, adding 6. You could simplify it and make it look like that. But for graphing purposes, this is really an awesome form. So what we're going to be looking at is this A, which in this case is a 3 or a -2. It can be a fraction. What does the A do to the graph? What does this number inside of the parentheses do to the graph? What does this number outside of the parentheses do to the graph? And again, on the outside, it could be a -8, a +8. What does that mean? And that's what we're going to be looking at in this section, and you're going to find that it's really quite easy. What we're going to look at first is what does the A do to the graph, okay? What does, and then we'll look at the H and the K. To tell you the truth, the first thing we're going to do is we're going to graph a basic parabola, okay, shape. Graphing a basic equation, our most basic equation. F of x equals x squared. We're going to plot points just as a review of how to plot points. And then we'll look at how to use the A, the H, and the K. And sometimes you won't have an H like in this one. You're not adding anything to the X. Sometimes you won't have a K. All right, and what does that mean if they're not there? Well, we're going to go ahead and graph these maybe the way you've done this before in Algebra 1 or before. We're going to plot points. So we're going to choose some points, some X and Y points. We're going to put those in. Again, remember, this means Y, okay, fancy Y. And choose your X's wisely. And again, it's up to you. What we're going to do is, in the first case, we're going to go ahead and we're going to pick 4 points. And I'm going to pick these 4 X's. And they could have been anything. But I'm going to choose some smaller numbers to work with. And some of you may want to choose larger numbers. You just need to make sure that if you choose them too large, they may not fit on this axis. Unless you change each of these marks to go by 10s, you can do that. Each mark can go by 2s. All right, just kind of be aware of that. We're going to make each mark worth 1. -1, -2. This will be 1, 2, 3, and so on. -1, -2, -3. So each mark will be worth 1. So let's go ahead. Let's put a -2 in for the X. When you square a negative, it becomes a positive. So this will be a +4. So we have 1 point for our graph. Let's go ahead and put in a -1 and square it. Again, it's negative, but when it's squared, it becomes positive. So a -1 times a -1 is a +1. If you put in 0, you get 0. If you put in +1, 1 squared is 1. 2 squared is 4. So I've created these points that I'm going to plot on my graph, and it's been a while, maybe for some of you that have plotted points. I'll write them out as ordered pairs. And remember that the first number tells you the x, okay? That would be your x value. And the second number is the y. And they're always in alphabetical order. So for our first point, we're going to go to a -2, 4. So you go to a -2 on the x, it's always first, -2, 4. And there's your point. That's the point, -2, 4. You're going to find with My Math Lab, it's actually pretty easy to graph. -1, 1 is our next point. So we go to -1 on the x, 1. I'm not going to label that. Then we go to 0, 0, which is the origin. Okay. Then we go to 1, 1, over 1, up 1. And then we go to 2, 4, over 2 and up 4. And when we connect these up as best as possible, that's what we end up with for our parabola. Now that is a graph of the solutions. So any point that you would choose on that graph would work in that equation, y equals x squared. All righty? Okay, let's look at the next one and we'll graph it. And when you look at your graphs on the notes, you don't have these axes drawn in there. You'll have to do that yourself. You'll notice that. Well, let's go ahead and let's plot some points for the next one. And then we're going to talk about the number in front and what's happening with that number in front. And if you'll remember when I showed you earlier, that number in front is the A. We'll be talking about it first, okay? And its significance in graphing. Well, we're going to go ahead and we're going to choose some points. And again, in this one, it's more important that you choose wisely because I'm going to be dividing I'm going to square the x first because we use PEMDAS. Exponents come before multiplication. You need to choose numbers for your x that are divisible by 2 because taking a half is the same as dividing by 2. So we need to choose wisely. In other words, I don't want to use a 3 because 9 cannot be divided by 2 and come up with a whole number. Whole numbers are a whole lot easier, or excuse me, integers are a whole lot easier to graph. So let's choose maybe -2, okay, -4, 0, and we'll do the 2 and the 4. Okay. We'll graph those 4 points right there. So let's go ahead and put in our -2. -2 squared is 4. Okay, when you put a -2 in and square it, you get a +4. So -1/2, 4. Half of 4 is 2. 4 divided by 2 is 2. Negative times a positive is a negative. So there's one of my points, -2, -2. Now let's put in a -4 into the function. So we're going to put in a -4 and square it. +16. You square a negative, it becomes a positive. And let's see, half of 16 is 8, or 16 divided by 2 is 8, and it will be a negative because a negative times a positive is a negative. Perfect. Let's put in 0. 0 is a nice number to work with. If you put in 0 and square it, you get 0. 0 times the number is 0. Let's put in a +2 rather than a -2. Is it going to change if I put in a +2 rather than the -2? Well, you should know that when I'm going to put in the +2 now. I square it, I get a 4 times a -1/2, which gives me 2. Okay, half of 4 is 2, or 4 divided by 2 is 2, and it'll be a negative. So I got the same value, okay, as I did with the -2, putting it in. 4, we won't have to do this too much when you're graphing with my math lab. I still get a positive 16. Half of 16 is 8. A negative times a positive is a negative. Okay, so now we're going to plot these points and we're going to see what our parabola looks like. Now let's -2, -2. So here's our x and here's our y. So we'll go to a -2, -2. Right here is our point. -2, -2. -4, -8. So we go to a -4, -1, -2, -3, -4. And then we're going to go down to a -8. -1, -2, -3, -4. 7, 8. There's our point. So we have a -4, -8 is our next point. 0, 0, our origin, excuse me. Okay. 2, -2, 2, -2, 4, -8. Okay. Oh, excuse me, I went 2, -8. Didn't go over far enough. So 4, 1, 2, 3, 4, -8. Okay. And we'll connect these up. Okay, so there's our graph. It looks a little different, but it has basically the same shape. It's just flipped over. All righty. Now, what we're going to look at is these points here. This right here, this point 0, 0, and the point on here 0, 0. This bottom point and this top point are called the vertex of the parabola. So either the very bottom, okay, or the very top. Now the vertex here is 0, 0. That's the coordinates of the vertex. This right here is a minimum. Okay, it's the minimum point on the graph. So the vertex is 0, 0, and that vertex is a minimum. Now let's look at this one here. The vertex is 0, 0. That's also called the origin, and this is a maximum, okay, rather than a minimum. So this vertex is the high point. Instead of calling it the highest point, we call it a maximum. This vertex right here is the lowest point. Rather than calling it the lowest point, we call it the minimum. All righty? So you've got a maximum and you have a minimum. And the maximum and the minimum are found at the vertex. Okay, always. So that's kind of nice. Well, what we're going to do is we're going to pick apart, now that we have a basic graph, a basic understanding, plotting points, it's a good review. Okay, we're not going to be doing this. Okay, we're going to look at the A. What exactly does that A do, that number in front of the x squared? Well, this is not a part of the notes, but what I did here, let me move this down so that you can see it, is I have graphed. Now, you guys, this Desmos is an online graphing calculator. It's free. It's pretty nice. It does really nice graphs. You just type in the equation. So those of you that don't have a graphing calculator for next year, you might want to remember Desmos. It's on, I think it's just desmos.com, but it's a graphing calculator. What I did in Desmos is I graphed three quadratic equations, And these, the A, which is the number in front, this number in front, I changed. And you can see what happens. Now, this red one, okay, this basic x squared, it's the most basic parabola that we have. It's called a parent graph. All right, all others are worked off of it. All others are shifted from the parent graph. So y equals x squared is the parent graph. How does the 5 compare to the parent graph? Well, the 5, which is a number larger than 1, narrows the graph. Now, those of you taking like the 1400 or even the 1000, they'll call it a stretch. So this 5, okay, if this number, this A, is larger than 1, like if it's a 5 or a 10 or a 2 or a 3, it will narrow it or stretch it so it's thinner. Okay? The graph is thinner than the parent graph. Okay, so it goes here. This is your 5x. You can't really see the color very well, but it's blue. What if you have a fraction or a number less than 1 for your A? It will widen the graph from the parent graph. So the 1/3 is wider than your parent graph. So the number in front, okay, if there is one, doesn't have to be, but if there is one, if it's greater than 1, it will narrow it. If it's less than 1, like if it's a fraction, then it will widen it. This is called a stretch, and this is called a compression. But for your purposes, we'll just say it narrows it and it makes it wider. Okay, that if you have a number. It's a positive. Notice all of these numbers are positive. But what if I have those same, if I have a 5 and I have the 1, I have a 1, and if I have the 1/3, what if I make those negative instead? Well, I did not graph on this one, the parent graph. Your parent graph, y equals x, is right here. This is your y equals x squared, okay? What it does, now notice these, I now have a -5. So it's narrower, but the negative flipped it. Here I have a -1. Here I have a -1/3. So the -1/3 is wider than the parent graph, okay? But it's flipped. So this, if it's a negative, it will flip it so that it's opening down. Here, if the A is positive, it opens up. So that's what happens if the A happens to be negative, if the A happens to be less than 0, which means it's negative, then it will flip and they will open down. But if the A is positive, like our last ones here, then it will open up. If this is larger than 1, like a 2, 3, even 1.5, like 3/2, 4/3, anything bigger than 1, it will be narrower. If it's a fraction here or less than 1, then it's wider. Okay. All right. So that's kind of what that's all the A does. Tells you if it opens up or down, and if it's wider or narrower. If you happen to have an A, sometimes the A is just a 1 like this in front of this one. Okay. All righty. Now, one other thing in dealing with these, let's talk again about the vertex. Okay. What's the vertex of all 3 of these? Well, the bottom on all 3 of these is 0, 0. So I'm going to write the vertex is 0, 0. Okay. All of these have a minimum. Okay. They all have a minimum of 0, 0. That's the bottom of the entire parabola. That's the bottom of the parabola. It looks like it's pausing, but I don't, maybe not. All right. The next thing we're going to talk about now, before we go on and talk about what does that H or the K do, is we're going to talk about the axis of symmetry. So each of these parabolas has an axis of symmetry. Now, the axis of symmetry is a vertical line. Vertical lines all have the equation x equals something. Now, the axis of symmetry will always cut through the vertex. So in other words, my axis of symmetry cuts right through the middle. Okay, and in this case, it's the y-axis. And if you were to fold these over, if you were to fold it across the axis of symmetry, they would match, the graphs would match. So the axis of symmetry is x equals, since it cuts through the vertex every time, it's going to be the x coordinate of your vertex. So x equals 0. That's going to be the axis of symmetry. We're going to practice this quite a bit. You'll be fine. All righty? Okay. Let's go on. Okay. To, again, let's go ahead. Let's look at the vertex. The vertex of each of these parabolas is the high point in this case. We're not going to look at our parent graph here, y equals x squared. We're going to look at these three here. The vertex, the high point, is 0, 0. These parabolas, all three of them, the vertex is considered a maximum because it's the highest point on all the graphs. The vertex happens to be the highest. And again, just kind of ignore that parent trap that I had there. The parent graph, not trap. Oh well. So here we have a vertex at 0, 0, and that vertex is a maximum. The axis of symmetry is x equals, it's always x equals. Okay, with what we're doing, it's always x equals. It cuts right through the vertex. So it's x equals 0. Okay, because the 0 there, it'll always match. See, not so bad. All righty, great. Let's now, we're going to talk about, and the axis of symmetry with these is, what does the H do? So we talked about the A. The A on each of these, we can automatically tell that the A is positive here. None of these are wider, so this is not a fraction on any of these. None of them are narrower than this parent graph. This is our parent graph still. So the A in all of these cases is 1. It matches the parent graph. But what about the H? What did the H do? In this graph, my H, in this spot, I have a 4. Well, what happened? Well, my vertex shifted, and it shifted to the right 4. Even though this says -4, it shifted to the right 4. So rather than the vertex being 0, 0, the vertex is 4, 0 is my vertex, okay? Because the H had to be a +4. When you put it in here, the H is a +4. I like to think of it as it's just the opposite. So if this is negative, you're going to go to the right 4. If this is positive, you end up going to the left 4. So the vertex has been shifted to the left 4. It's the opposite of whatever that H is. So you just take the opposite, would be -4. It shifts it to the left 4. This one Okay, this -4 will shift it to the right 4 from the parent graph. And we're going to practice numerous of these. I just want to give you kind of a basic overview of what the A did and now what the H does. Let's look at one more H here. Let's say that y equals, I'm not going to put an A, I'm not going to make it wider, narrower, flip it. What happens if I have x plus 8 squared? Where would this be? Since it's positive, we do the opposite. We're going to go to the left 8. We're going to shift it from our parent graph. We're going to shift it to the left 8 and draw our graph. So the shift is kind of, just think of it as the opposite shift. If it's positive, go to the left. If it's negative, go to the right. Okay. So this would be y equals x plus 8 squared. And again, I didn't make it wider or narrower. Okay, so now we know what the vertex is of each of these. The vertex here was a -4, 0. The vertex 0, 0. The vertex here is 4, 0. The vertex here is a -8, 0. Each of these is a minimum. So this is a minimum, minimum, minimum. On each of these, you have a minimum value. It's the bottom, it's the lowest. The vertex is the lowest. So it's a minimum. But let's talk about that axis of symmetry. All right, so let's look at the axis of symmetry of each of these 4 graphs. Here, the axis of symmetry cuts right down through the middle. And they're all vertical lines, every one of them. Okay, this one we kind of talked about already. So we have the vertex. Okay, now all of the axes are vertical lines, and if you notice, if you were to fold it over this vertical line, the 2 graphs would match up. What's the equation of this vertical line? X equals, okay, all of these run through the -8 on the x-axis. So x equals a -8. Just look at your vertex and that'll tell you what all the x's need to be. Here, this is the equation of my axis of symmetry. X equals a -4. It hits the x-axis at a -4. Look at the x-coordinate of your vertex. This one right here, x equals 0. Okay. Look at your x-coordinate of your vertex. Here, the axis of symmetry is 4. Okay, look at your x-coordinate. It hits the x-axis at 4, hits at 0, hits at a -4, hits at a -8. And they're all vertical lines, x equals. Alrighty? Okay, perfect. We have one more to do, and that's the K. What does the K do? Well, what I did is I took the one with the 4 here, and I added a 2 to it. So if you'll notice on the last page, I had x minus 4 quantity squared. It was down here. So let me get that back up. I took this green graph here, okay, x minus 4, it shifted to the right 4, and I added a 2 to it. What happens if I add a 2 out of the parentheses? Not in the parentheses, out of the parentheses. If you add that 2, notice what happens to the graph. It went from here and it went up 2. Okay? So what that number out there does is it's a shift, but it's an up or down shift. But it's not opposite like this one. This one went to the right 4 and up 2. My vertex is now very different than what it was before. My vertex is 4 because I went to the right 4 from my parent graph, and I went up 2. So there's my new vertex to the right 4 and up 2 from the parent graph, to the right 4 and up 2. So my vertex is now 4, 2. It's a minimum, all right, because it's the lowest point. I didn't flip it by putting a negative in front. If I put a negative in front, then I'll have a maximum. Okay. Let's look at this one. This one right here started out right here on the x-axis, okay? It was a negative 4, 0. Where's the equation? There it is. There's my equation. I kind of crowded it with my last one. X plus 4 quantity squared. What if I subtract 2 from it? What's going to happen to this graph, this blue graph, if I subtract 2? I've already gone to the left 4. What does adding or subtracting a number? What does subtracting a number do? Well, by subtracting a number, I dropped it 2. So my vertex is a negative 4 because you take the opposite there, and you went down 2. So there's my minimum value. It's the vertex, negative 4, negative 2. So this number that you may add or subtract is an up and down shift. If you add, you go up. If this is a subtraction, you go down. All right, it's not too hard. But I still want to look at the axis of symmetry. Because we shifted it up or down, will that change the axis of symmetry? Well, the axis of symmetry is still a vertical line, and it's x equals negative 4. So shifting it up or down did not change that axis of symmetry. It's based on the right or left shift only. It's based on whatever the x coordinate is. Here, the axis of symmetry is still x equals 4. Still runs through the x coordinate. Okay? All right. Well, we're going to practice some of these ideas, and we're going to do some graphing, and then we're going to look at the homework, and I'm going to run through how to use my math lab in graphing these things. Okay, now we're back to your notes. And again, here it's just kind of some instructions. If h is positive, then you shift it to the left. If the number inside the parentheses is positive, you go to the left, it's opposite. If it's a negative, then you shift it to the right. Okay. And the vertex helps you find the axis of symmetry. It's just x equals whatever your x coordinate of your vertex is. Okay, let's graph these. You know, I don't want to spend too much time because you're not going to be graphing them by hand. You're going to be using my math lab, but just kind of get the basic shape. Okay, let's talk about, we're going to find the vertex first, and then we'll talk about what's happening with that. I know that I'm going to the left 3. So we always start at 0, 0. I'm going to go to the left 3, and I'm not adding anything. So that means I'm just going to go to the left 3, 1, 2, 3. Why left? Because that's positive. So my vertex is a negative 3, 0. The reason it's 0 is because I didn't have an adding or subtracting here. I didn't shift it up or down from the basic parent graph at 0, 0. It's not shifted. Okay, what do you know about the negative? Well, that negative tells me it's going to be opening down. Okay, this number out here is negative. It's going to be opening down, and it's going to be a little narrower than the parent graph because that's a 2, so it's going to be thinner. Okay, stretched, it's going to be thinner. So if you wanted to, and oh, the axis of symmetry. We have our vertex. Let's talk about the axis of symmetry. The axis of symmetry, because we're going to use it to graph, and my math lab does this for you automatically, the graphing using this. Okay, the axis of symmetry runs through the vertex, and it's going to be x equals a negative 3. Okay, so let's pick a point. We're just going to do one point. We want to pick a point to the right or to the left of our vertex here. And we're going to plot it, and then we're going to use it to plot on the other side, knowing that it's symmetrical. Let's pick the point, I don't want it too large. Let's go right next to here. Let's put a -2 in for the x. So, you know, rather than do a bunch of these, we're just going to do a -2. Okay, I picked a number to the right of our axis of symmetry. So if you put in a -2 in for x, if you pick close to the axis of symmetry, the numbers are usually really nice. I just happen to pick -2 to put in. So you have a -2, PEMDAS, parentheses. Okay. Exponents, 1 squared is 1. Multiply. So there's my y coordinate. -2, -2 is the point. -2, -2. If you put in a -2, you get a -2. So I go to a -2, -2. Well, I know it's symmetric. So this is 1 over. I can go 1 over on the other side. And there's your other point. And then we'll just kind of sketch it out. So on My Math Lab, you'll need to find one point, and it will automatically do this other one for you. Which is nice. But because of the symmetry, it's the same distance from the axis of symmetry. All right, because of the symmetry. All right, let's try another one. Okay. Here, I know we're gonna graph the vertex. Well, sorry, I missed something up here. And that was the range. Okay. Well, let's go ahead and we're gonna add to this. This vertex, -3, 0, is our vertex. It's a maximum. Okay. And what is the maximum value? Okay. So we have -3, 0 is our vertex. This vertex is a maximum. It's the highest point. When they ask you for the value, the maximum value, they want the y coordinate. Okay. So I'm running out of room here. So they want the y value here. I'll put it up here, sorry. So they want, whenever they ask for a value, they want the y. So the maximum value is 0. It's the y, would be the maximum value. All right, it's the y coordinate. Now we have our vertex. We have our axis of symmetry, came from the x coordinate. Our maximum value comes from the y coordinate, okay? And we want the range. Well, the range is dependent upon the y, all right? So it's, you go from the highest down. So our range, the highest is 0, and it goes to -infinity, okay? So the range is 0 to -infinity. That's just kind of a review of what, oh boy, chapter 3, 4, somewhere in there, okay? Alrighty. So a review of the range. The range, it helps to know what the maximum value is or the minimum value. So you'll either be going from here to -infinity, or you'll be going from the vertex up to +infinity. All right, okay. Now let's go ahead and, excuse me, let me look at this one right here. Okay, we've got a negative, our vertex is, we're going to go to the right one, but we're not going to go up or down. So we're going to go to the right one from the parent graph at 0, 0. We're going to go to the right. Why right? Why right? Because it's negative rather than positive. Now we have our vertex. It's the point 1, 0. Okay, that's our vertex. I know it will be opening up. And I know because this is less than 1, it's going to be wider than our parent graph of x squared, where that's just a 1. It'll be a little bit wider. So let's go ahead and plot a point. Let's pick an x. Let's see. We want something that we can divide by 2. Okay. Well, let's go ahead and put our axis of symmetry in before we pick that, because we want to pick a number just to the right or to the left. Okay. So our axis of symmetry is x equals 1. And we need to pick a number to the right or to the left, but we also want to pick something that's divisible by 2. So let's think about this. If I put in 0, okay, which is just 1 over, if I put in 0, 0 minus 1 is -1, squared is a +1, but you end up with 1 times 1/2, and you still end up with a fraction. So let's try 3. 1, 2, 3. Let's try putting in the number 3. So if I put in x is 3, do I get a number divisible by 2? Let's look. 3 minus 1. Let me write this out. So I just put 3 in for the x. So we have 1/2, PEMDAS, parentheses, exponents, and then multiplication. So 3, 2. So let's go to 3, 2. 1, 2, 3, 1, 2. There's our point 3, 2. It's 2 away. So on the other side, 1, 2. It's also 2 away. It's opening up, which is what we expected, because this right here is a fraction. And it is a little wider than our x squared. Yeah, it worked. Okay, now let's go through everything. We've got the vertex. We have the axis of symmetry. I know that this is a minimum. Okay, the minimum value is 0. When they ask for the value, they want the y coordinate. The range then, if the minimum value is 0, it's the y coordinate, the range goes from 0, including 0, up to positive infinity. So you'll either be going up to positive infinity, or you'll start at your y coordinate of your vertex and go down to negative infinity. Those are your only 2 choices, which is kind of nice. Okay, perfect. All right, let's do another one. I'm not sure, we may not get to all of these. We'll see. We might just do one more and then look at your homework. Okay, now let's put all of this together with a k, because we haven't really done this k here in a while. So let's go ahead. We've got our vertex. Our vertex will be at a +3. We're going to go to the right 3 and down 5. So we're going to go to the right 3 and down 5. Okay, so the parent graph started at 0, 0, but we're going to go to the right 3. Why did I go to the right? Because that's a minus and it's always the opposite. And I went down 5. So my vertex is 3, 5. Let's look, will this be opening up or down? Well, looking at this, the number in front is a +1. So it's going to have the same width as our parent graph of x squared. It's not going to be wider, it's not going to be narrower, and it's going to open up because it's positive. Now the axis of symmetry is a vertical line. And vertical lines have the equation x equals +3. You can just look at your vertex to see what that number will be. Okay, now minimum. Well, let's go ahead and graph it, and then we'll look at the minimum value, and we'll look at the range. So let's pick a point. We're not multiplying by a fraction, so it doesn't really matter. But if you pick a point just to the right of this or just to the left, you'll have numbers that are easy to work with. So I would either pick 4 or 2. All right, let's pick 4, because then we'll have a positive inside. So I'm going to pick a 4 to put in for the x. So that gives 4 minus 3 squared minus 5. PEMDAS, we have parentheses, exponents, and then we'll add or subtract. So we have -4 as our y coordinate. So we know we have the point 4, -4. Because of symmetry, I'm a distance of 1, so I go a distance of 1 on the other side, because they're symmetric about that line. So I can sketch the graph. Okay. I can tell that I have a minimum. Okay, I have a bottom number. The minimum value, we've always get our values as the y coordinate. So our minimum value is 5. That's our minimum value. That also helps us with the range. The range is also based on the y. The smallest y, okay, when we find our range, okay, the range is based on the y's. The smallest y is a 5. These will always be including that. And we're going up, so it's a positive infinity. Great. Okay. All right. So what I think we're going to do now is rather than finishing these, we're going to go ahead and go to your homework and look at those individually and find them. And if we have time, we'll come back to this. I just don't want this video to be too long. So now what we're going to do is we're going to look at some of the assignment. Okay, so let me move this over. Okay, hopefully it didn't get me out of it because I was waiting too long. All right, there we go. I'm going to start with number 3. Number 1 and 2 just deal with, does it open up or down? According to the A, it's really not too bad. Okay, so this is what your number 3 will kind of look like. And we have 17x squared. So we know the vertex is at 0, 0. How do I know, and why do I know that the vertex is at 0, 0? Because you're not shifting it. You're not adding or subtracting anything to the x. You're not adding or subtracting after the x. So the vertex is at 0, 0. Now there's a couple ways you can graph this. You can use this button here and use a pop out. Let's do that. And then the next one we'll use the other one. All right, so click the graph and choose a tool. So we're going to have a parabola. Up or down, you use this one right here. So you click that and you go to your vertex, which is 0, 0. Okay. Now, in order to know where the next point is, does it go up like this or does it go down like this? You need to find one point, okay? I suggest we go just to the right of our vertex. How about if we put in the number 1 into that function? If I put the number 1 into the function, I get 1 squared, which is 1, times 17 is 17. So I need this second point to be 117. Now, how do you know where you're at? Look at that top right. I can't really point to it, but now it's at 1/8 on the top right there in the box, and I want 117. See, there it is in that yellow part. It says 117. Notice how narrow it is because our A is 17, which is a high number. So the higher it is, the narrower those get. And then you can save it, and then you can check your answer. And let's see, a lot of times on these, if you miss it, sometimes they want you to graph the axis of symmetry, which we'll go through, but this one doesn't. So then you just check your answer, and we got it right. So we'll go to the next question. Number 4. Okay, number 4 is kind of just like this last one we did. It's just that we have a -2. So we expect our graph to go down, to open down, rather than up. And what we'll do on this one is we're going to go ahead and we're not going to use this pop-out box. We're just going to click on the graph without going to the pop-up box. When you left click on that, on the bottom, we get our tools. All right, so I just clicked on the graph anywhere and these showed up along the bottom. And I want a parabola that opens up or down. It'll always just open up. Just use this one. And I need my vertex. Well, I'm not adding or subtracting anything, so there's no shift. So I'm going to go to 0, 0. Now, if you look to the bottom left of the graph, you can see what the coordinates are, where my cursor is, which is at 0, 0. Now I need another point. Well, let's put in the number 1 again. So if you put in 1 and square it, you get 1 times a -2 is a -2. So I'm going to go to 1, -2. And if you look at the bottom left by the graph, you'll see the coordinates of where your cursor is. And it's 1, -2. It opened down, which is what I thought. It's a little narrower than just a plain old x squared apparent graph. And then you can just check your answer. It usually turns blue. Oh, well, let me check my answer here. Yep, okay, it liked it. Here we go. This one right here, we're going to be shifting. Okay, so you see, these really aren't taking too long, but be aware. When you get to number 5, notice the directions. Use the graphing tool to graph the function as a solid curve and the axis of symmetry. They want the axis of symmetry put in there. So as a dashed line. So let's go through that. Let's use the pop-up. Makes it a little bit larger. Pop out. So I'm going to go over here. And I want a parabola. We'll graph the parabola first. Okay, now if you kind of look over here, it's kind of light, but I think we can see it. We have a shift, don't we? So we're going to shift it to the left 3, but we're not going to go up or down. So we go to 0, 0, where our parent graph is. We're going to go to the left 3, 1, 2, 3. Pay attention on that top right of this box, -3, 0. Okay. Now we need another point. And isn't it kind of nice? You only have to do 1 and then it kind of does everything else for you. What do you want to put in there? You could put in a -2. You could also put in 0 because look here, it goes clear up to 20, your y-axis. So if you put in 0 for x, 0 plus 3 is 3. When you square the 3, you get 9. So go 0 up to 9. And look at that top right. Make sure your cursor is at 0, 9. It is. Okay. Now, sometimes you'll stop here and you'll miss it. And the reason is they also want the axis of symmetry. So how do we do that? Well, the axis of symmetry is a line. So you go over to your tools and you're going to do the line tool. When you press the line tool, you're going to come over here. Your axis of symmetry, I just like to start at the vertex, -3, 0. And it's a vertical line, so go straight up to any point that goes straight up. Now, the axis of symmetry is a dashed line. So, you know, you can either push this before or just after. Just make sure you make it a dashed vertical line. And then we'll save it. There's our graph right there. And we check it. Okay, great. All right, let's look at, oh, that one's kind of the same, only it goes to the right 3. Let's do something else. Let's do maybe a harder one. This one is going to open up. I want to do one where we have to find, let's do this one right here. This is a good one. So we have to choose the correct graph rather than graph it. Well, I know that the vertex on this graph is at +8, 5. So look for something that has a vertex at +8, 5. Also, okay, I know it's opening up. So you can use the process of elimination. It cannot be A because we're going to go to the right 8, not to the left 8. It can't be B because it opens down. Our A is positive, it opens up. Let's look at C. And again, you can enlarge these. We want an 8, 5 vertex. What does each tick mark equal? Well, if you look here, this is 20. So this must be a 4, 8, 12, 16, 20. So, and again, we have 4, 8. Okay, so this one looks very promising because this is 8, 5. Okay, so this one looks good. And you could look at this one just in case. This is 4, but you needed to be at 8 for your vertex. The vertex was 8, 5. So I think I said 8, 4. So this is the one that works. Our vertex is 8, 5, a little above the 4 mark. So that wasn't so bad. You guys will be able to reason through it a lot quicker. Okay. Does this have a minimum or a maximum? And again, we're looking at this C. We got it right. Well, it has a minimum. Yay. That's not, see, final check. Okay, great. We're doing perfect. What's the value? Now remember, the minimum value is the y. They even tell you the minimum value of y is 5. Look at your equation or your vertex, 8, 5. So the minimum y value is 5. So we'll put a 5 in there. Oh, yay. What's the range? It goes from 5, because range is based on the y's, 5 to infinity, including the 5. So it's this one. It goes from 5 up. Check answer. All right, so we got that one right. Notice I really haven't, this whole assignment, you really don't need to write down a lot. Hey, oh, let's try number 9. And then maybe this will be it. I think this is all you need to know. Let's try this one. Okay, we need to pick the graph, but let's find the vertex. We'll kind of look to see if we're opening up or down, see if we can eliminate some of these. The vertex is a -9, 5. All right, so the vertex is a -9. We're going to the left 9 and up 5. Well, let's look. Oh, and it opens up. It's wide, but it opens up. So it can't be A, because that opens down. It can't be B, because that opens down, and our A is positive. So it opens up, and it's a -9, 5. It cannot be C because it's not a -9. It's going to the positive. Let me explain that. See, this went to the right 9, but we don't want to go to the right 9. We want to go to the left 9. So it's got to be D. Okay, you can look at it, I guess. So we have a -9, 5. Be aware of your tick marks. The tick marks are all like 4s. Okay, so that's not so bad. Okay, do I have a minimum or a maximum? Well, in this case, because it opens up, oh, there's our D. Because it opens up, I know that the vertex, that is a minimum. It's the lowest. The vertex is the lowest. Final check. Good job. The minimum value of f is, what is the minimum value f of x? The minimum value is the y coordinate of your vertex, which is, our vertex is a -9, 5. So it's 5. And check answer. I want to do one more where we have to graph, and maybe you guys don't need it, but I'll try to do one more. Okay, and because it's a minimum, we start at 5 and we go up. So it's 5 to infinity. Check answer. Awesome. We want to graph the following function, find the vertex, the axis of symmetry, the maximum or the minimum value. Let's go ahead and try this one. And this will be the last one. I think you guys can kind of figure it out. Our vertex, as an ordered pair, we have to type it in. Our vertex is a -3. -3, -1. So in other words, we went to the left 3 and down 1. So our vertex is a -3, 1. Check answer. Okay, thank you. The axis of symmetry. The axis of symmetry, type an equation. It's an equation. It's always x equals, and it will always be the x coordinate of the vertex. It'll cut down through that vertex. So -3. There we go. Okay. Is there a minimum or a maximum? We didn't even graph it. Can you tell? Sure we can. I know it opens up. If it opens up, I have a minimum. And the reason it opens up is because the A is positive. If it opens down, then I have a maximum. So this one opens up. So I have a minimum value of, what will that minimum value be? It's the y coordinate of the vertex. So that's what they want, is that y coordinate of the vertex. That vertex tells you a lot. So the minimum value is -1. So the x tells you the axis of symmetry, and this tells you the minimum or maximum, depending on if it opens up or down. Check answer. Okay. I wonder if they're going to have us graph this. Oh, yes, they do. I'm going to use the pop out, which is bigger. I need a parabola. Do they want us to, oh, I forgot to check to see if they want us to graph the axis of symmetry. Oh, well, we'll see. All right. So it's a parabola. You go to your vertex, which is a -3, -1, -3, I'm at -2, 0, -1, go down 1. All right. Now we need another point. You could probably use 0 in there. We don't have to really be too picky because we don't have a fraction out front to divide or anything. So you could use 0. You could use a -2 if you wanted to. It gives you nice, numbers to work with. Let's put in a -2. And I'm going to talk you through this since I don't have my document camera up. But if you were to put a -2 in, because what I'm doing is I'm just going to the right of my axis of symmetry. If I put in a -2, -2 plus 3 is a +1. When you square the 1, you get 1. 1 minus 1 is 0. So I go over to 1, or sorry, -2, 1. Okay. Now, what happens if you didn't like that? You could have put in 0. If you put in 0, you get 3. 0 plus 3 is 3. Squared is 9. 9 minus 1 is 8. So let's see. Let's see if so if you were to put in 0, oh, this is a good example. It shifted on me. So you can clear it with this button. Okay, and this will clear. Do you want it to clear it? Yes. So you can clear and start over again. So let's go to a -3, -1, -3, -1. Oops, sorry, gotta push that. -3, -1, yes. And then we can go to a -2, or we can go to 0, 8. Right there. Did we put the -2 in right? If you put a -2 in, you get 1. So yeah, you get 0. Yep. So you put a -2, 0 in. Yep, it would have worked. Both of them work. I think I plotted it wrong. So -2, 0 is what we could have had, or you put in 0, 8. Now you can save it, and you have your graph here, and then you can check it. I don't think they wanted you to graph the axis of symmetry, so we'll just check it. Yeah, it didn't want us to. Okay, well, I'm hoping you're kind of getting the hang of this one. Now this one's going to open down, so it's going to have a maximum value. And I think that's probably it. It's kind of a long video, longer than what I expected. But I'm hoping you have some idea of how to graph. And notice most of this assignment, you don't really have to write down anything. Okay, I just wanted you to be able to graph using My Math Lab, and to kind of understand what's the axis of symmetry, what do you mean by minimum and maximum value, what does the A do, how does the shift work, stuff like that. So, all right, well, I think I'm done, and if you have any questions, I can always go through it with you, maybe a little bit slower, or go through different parts that you might have missed, okay? There was kind of a lot in this last section, but the nice thing is it's the last section, which is awesome. And then we'll start reviewing for the final. Okay, all right, well, you guys have a great day or great evening, I guess it is for me now, and I will talk with you or see you, and let me know if you have questions. All right, take care.